So, as I was saying, I will record the lectures. Most of what we're going to do in class is not going to be me talking to you, but I figure I just go through the trouble today in case. I think most students are here. There might be a couple of folks missing, but anyway, if there's something like super critical and I want to show you something or share someone else's YouTube video or a neat drawing or a website, I'll put this out there and I'll say, hey, I posted a 10-minute, 20-minute video. Go check it out. It'll be important. Or, if there's something that somebody like everyone's struggling with, I'll try to cover that so I can, blast that out to the course. But let's just go through the syllabus a little bit. So Brian Hoover developed this course. He's taught here at Missoula College. He's also taught over at Sentinel High School. And like I said, he's done a fantastic job putting the course together. Did Lee cover a little bit of this too, or not so much?
He covered.
How much? I'm just wondering how much of that, because I don't want to.
Like we drew some objects, and we got up basically up to the lettering.
Okay, good.
And there was an assignment, but it wasn't clear.
Okay.
What the assignment was.
We'll do some of that today. I sent him a suggestion, but we'll do some of that today. Lettering, very important, especially for the accountant in the room. So yeah. Okay. So again, this is a great course to start in on, and I do have a revised version of this thing that I'll post. But anyway, my email, just for everybody in case you haven't seen it yet, and also, well, shoot me an email. It's not a problem. It's just Bradley.Layton. It's an N. I do work on my own lettering at umontana.edu. So Bradley.Layton at umontana.edu. That is my email address. And now it's funny, now I think about it, I typically write in uppercase letters, and I know that, I remember the moment in time when I decided that's what I was going to do. I was sitting there in drafting class in high school. I'm like, I'm going to do everything in block letters. Hey there, afternoon. We'll embarrass you later.
I got held up at the university. I have a class right before.
Oh, okay, it's not a problem.
Yeah.
This has all been recorded for your later viewing pleasure. So anyway, as I was saying, this is a great place to start. The textbook that we have is a perfect intro to technical drafting. Technical drawing or engineering is not required. I am going to throw in some engineering concepts as we go through the course. As I mentioned, I promise I will have a practicing professional architect come in and talk to you a little bit about his work, because it sounds like that's where a lot of you are thinking of heading with your career. So I'll tackle some of the engineering side. I'll let him tackle some of the architecture side. Those are two of the professions. If you become a professional draftsman, those are the two of the professions you will interact with. It's also possible you'll interact with professional machinists, and they're probably even rougher than the architects and the engineers. Just throw it back at you if it's not perfect. So. Yeah, okay. Who has not taken a geometry or a trig course? Okay, what, I'm going to work on names here, but Nick, what's kind of the highest math you've had?
Algebra, probably.
So you've had algebra? Yeah, well, and that's stuff I love. I mean, I love geometry, I love trigonometry, and I don't mind one bit doing some refresher on that. I mean, it's stuff that comes very naturally and second nature to me, so not a big deal. It says that trigonometry is useful, but not necessary. Okay, and one thing that's really important here that I really can't emphasize enough, and I will admit I am frequently guilty of this, but the word standard And that's really what we're aiming for, and that's where the book is going to come in to be very handy to show you what like exactly what a center line looks like. It's not really negotiable, it gives exactly what a hidden line looks like, et cetera, et cetera. So they're, very specific standards, so as soon as you know them, you don't have to think about it anymore. It's just easy for communication. Okay, and then CAD, sometimes CAD means computer-aided drafting, sometimes it means computer-aided drawing, either one is fine. We will do some perspectives, and that's gonna require you to think a little bit about, geometry in general. Different views. It's gonna be really handy that we look at, top, side, and front views. Sketching, we already mentioned the importance of sketching just as a first draft. Standard scales. Do you have a scale there with you in your pack there, Tom? Just wanna- So the scale, I'm not going to go into too much detail. I'm just going to hold it up right here. But this thing is actually really well designed. You can see that it sits on your table. You can pick it up. It's not as sophisticated or as fancy as a slide rule, but basically, just think about this thing as something that as soon as you set it down on your paper, it tells you exactly how many feet or inches you have in that little micro world that you're living in. So we mentioned previously there, Kimber, I said, what scale do you want to, do large scale things, small scale? The whole point, this thing does all the math for you, so you don't have to think about it. It just takes the feet and inches from our scale and shoves it down onto a sheet of paper. So it also provides a nice little straight edge, so you can measure and draw at the same time. So handy. I'll just keep this here for a second. Sections, and the best way to think about a section. But maybe one thing I can just sort of hold up my phone here, and I can see that if I were to take this phone and slice it, one thing that I would notice at the section is I would actually see this little lip. If I'm looking at it from the end, I don't know that lip is there, right? It could be solid, it could be completely hollow. Once I do that section, I look in and like, oh, this thing looks like kind of a little bit of a U shape to it. So the section allows for easier visualization. So it cuts down on the number of dashed lines that you have to use. That's the purpose of drawing sections. Dimensioning. Anyone maybe heard of Occam's razor before? There's this whole thing in physics, maybe you've heard of it. And the whole point behind dimensioning is that it should be as simple as possible, but not simpler. You need all of the dimensions on that drawing. You don't want to clutter the drawing with dimensions, but you need a sufficient number of dimensions so that the entire thing can be, the entire part can be drawn. And it's really up to you as a draftsman to get a little bit creative as to how to minimize and simplify just the amount of pencil lead you put down on the paper. And the whole point there is to keep it as simple as possible without missing any information. Tolerances, pretty important, especially if you're going to go put a window, a 30-inch by 36-inch window into a house. You're going to want to make sure that whoever's building the window does not build the window any wider than 30 inches, or if they do, you know how much wider than 30 inches, and whoever's building your house doesn't build the window, the hole in the side of the house any narrower than 30 inches. Now, another thing, very important, in this world we live in, there is no such thing as exact. Like, oh, there's no such thing. Nothing is exactly flat, nothing exactly square, nothing weighs an exact amount. We were taught that in quantum physics 100 years ago. So there will always be tolerances. I mean, there will always be a gap. There will always be an error. And so it's up to you as the draftsman to determine and just to think ahead. Okay, I've got the window coming in, I've got the hole in the wall coming over here. We might even get in a little bit into thermal expansion. Everybody's heard of the Golden Gate Bridge. Golden Gate Bridge was built. They designed that so that to the hour and minute when they put in the last beam, they knew what the temperature of the bridge was going to be, so it was the right length, so they could put the last chunk in. Because if they built that last beam, and it's too big, well, what do? You gotta go and cut it off and remachine it. If it's too short, you don't stretch it. So, the tolerances are important. And again, we're not getting into physics of thermal expansion and all that, but that's the whole point, because you've got the drawing in your mind, and you've got it on the paper, but it's going to become physical reality. And when somebody's dumped millions of dollars into their design, or tens of millions or billions, if you're designing so the next maglev train or whatever, the tolerances better be right on. Okay, so I can't really stress that enough. And there are very specific ways to do it, where it can be minus 0.01 or plus 0.04, et cetera, et cetera. So we'll get into that. Okay, I've already explained what the role of graphics are. Dexterity too, it's true, just like welding or sewing or whatever, it's a hands-on experience, so practice makes perfect in that. Accuracy, I cannot emphasize recognized standards enough, or conventions, and then this book is going to be great at illustration techniques too. Solve basic descriptive geometry problems. We'll get into that. We'll talk a little bit about bisecting angles or making circles from 3 points. All that's going to be fun. We'll also look at the golden ratio, appropriate methods, depending on what kind of, paper, ink, pencil you're going to use. Orthographic sketches and projections, and then, that'll be a good one. Sectioning techniques I just mentioned. Dimensioning, role and standards, cannot overemphasize the role of tolerances, and then, we'll talk about engineering too. Perfect. Okay, everyone has the book, the engineer's drafting kit. So I've already shown you the scale. Does your kit have a lettering guide with it there?
Has engineer triangle scale, 12-inch high cross section.
So you do know I have a lettering kit. Does anybody have a kit with lettering? All right, I'm gonna have to buy those separately.
And this was the one that, I just copied the name into Google and.
Okay, well, I might end up just buying some okay, so here's just lettering by hand, and that's some of what we're gonna do here today. You do have a compass, though. You better have a compass. Divider, a couple triangles. Okay.
6-inch compass,
Perfect.
6-inch divider.
Oh, perfect.
Triangles.
I saw the French curve in there.
Curve,
Perfect.
protractor, tracer lead.
Okay. I think the only thing you're missing is the lettering template. Well, so we can grab some of those. Okay. So, in my mind, really the most important thing is this final project. I don't expect you to have something in mind today but I would like you to start thinking about it, just, and really this is important because going forward into the job market, you're going to want to build a portfolio. I mean, you're going to want to have a set of things that you've created, that you've designed, that you can show potential employers. Right now, I'm working with a team of engineers and scientists, and there's some fairly sophisticated technologies that we need to have built for us. And so we've been interviewing engineers and draftsmen, and it's pretty impressive what some of these guys can come up with. So I'm not saying go crazy over the top in this first semester, but on the other hand, I would like you to start thinking now about what what your final project might look like. Maybe it's your dream home, maybe it's some kind of landscape, maybe it's some kind of machine. You name it, but just, think about what your final project looks like. That's the most important thing for me. We'll do these exercises in class, and the quizzes will be based, mainly on the textbook, but, that's really what I'm looking forward to are your final projects. So even though I am recording this, it's not an online course. Attendance is recommended. If you can't make it, you can at least catch up with some of these YouTube videos I'm going to assign. I'm going to be strict and say if you turn something in late, it's not going to get scored. And an excuse is that I got sick yesterday. Well, you should have started before yesterday. I mean, all the assignments are laid out, so just plan ahead. But if something does happen, some circumstance beyond your control, just let me know, and we'll negotiate it properly. The quizzes are timed. Again, there's a broad window for taking the quizzes. I'm fairly leaning on that, so you gotta do the quizzes. No makeup unless we talk about it. There's a final project instead of a exam, so that's really what like I said, I'm looking forward to. If there are any issues here, just let me know. We'll keep that discreet. I don't think there are really any opportunities for cheating in drafting class, for goodness sakes. I mean, hey, can you draw my thing? So I don't see that as a do my final project for me. So anyway, well, that's the syllabus. So okay, and I'm just going to put.
Take a look at where we are and move right now.
Yeah, I will. Yes, I just wanted to get that. I will. Yeah, I will. Yeah.
Some of those dates are off too.
I know.